Before I do this last topic, since we're at the end of the unit, can I just do a little bit of a review of some of the skills I hope you have? So, just going to write this off on a new page. The first skill I need you guys to have, you need to be able to factor or expand. So like, for example, if I gave you x with x plus 2, do you know that that's x squared plus 2x? Do you possess that skill?
Yes.
It's like literally the first thing we did. Second thing, can you solve quadratics? That was like another week. So if I gave you x squared plus 5x plus 6 equals 0, do you possess some skills to solve that somehow? You have options. One of the options is factoring, the other option is the quadratic formula. Then the third thing, we talked about radicals. No, actually before that, there was a topic that only you guys have. It's a system of equations. So that's either doing substitution or elimination. Do you know how to solve something when there's x's and y's? Next skill, can you work with radicals? And I mean, there's a lot to deal with there. Do you understand how to like take a number outside of a radical? Do you understand how to put a number inside a radical? Can you FOIL radicals? Can you add radicals? Can you multiply them? Can you do, you know what I mean? So basically, in general, can you deal with things that have square roots? Then the last little while, can you work with rationals? So these are square roots. These are fractions. To be honest, that's the main part of the section here. Today, we're just adding one more thing to it. It's called absolute value. Thank you. And I promise you, absolute value is not hard. Full money back guarantee here. Whatever you paid me, I'll give you back. Okay, someone get gold. I promise. So this is not the hardest one. So, does that kind of make sense in terms of things for you to study for? Studying for math is hard because like it's not like social studies where you can read through your notes and memorize what the heck imperialism is. I don't know. Is that a word you guys use?
Right.
Sure. Right? It's different. It's even compared to chemistry. So that's why I just pepper you with assignments, because the best way to get better at math is just to do more math. So, but in general, if you want to look at topics, I think these are the main 5, and then this is the last one. So I told you guys a couple of you yesterday. Absolute value, it's a very straightforward operation. Do you know how like squaring is an operation? It means multiply by itself. Or square rooting is an operation, or adding and multiplying and subtracting and dividing are all operations. Absolute value is an operation. It's a very odd, not odd the number, but like it's a very weird operation. It almost seems purposeless. It seems dumb. It is dumb, okay? Just so you know, it's dumb. Here's how it works. Absolute value basically means if you have a positive number, it stays the same. Literally do nothing. If it's a negative number, it's now positive. That's it. That's absolute value. It is. It's kind of dumb. It basically means no negative numbers. So like if I said absolute value of the number 5, you would say 5. If I said absolute value of the number -7, you would say 7. That's it. That's what absolute value is. Like it's fairly simple.
So like, why did they teach us this like 3 years ago?
Because to be honest, it's not purposeful. Like it's not hard, right? So it's not that purposeful. Let me show you how it looks when you do algebra, though. Okay. There is actually a little bit of usefulness to absolute value. For example, whenever you do a word problem, let's say that your answer was somehow -5. -5 was the length. You can't have a length of -5. Does that make sense? So sometimes we just ignore the negative and say, well, it must have been +5 then. Does that make sense? So let me walk you through some examples. Let's just start with that. You use up and down, like vertical lines is the symbol for absolute values. There's 2 horizontal lines written there. One thing I'm going to point out, make sure that you find a way to distinguish between these lines and the number 1. So like I might try to write my number 1s like this from now on, just to make sure I don't think that this line right here is a 1. Either that or write them like really tall so that you don't accidentally think it's a 1. So absolute value of 5 is 5. Absolute value of negative 5 is 5. And by the way, absolute value of 0 is 0. Okay. My goal now is to use this possibility and show you how to solve eventually what happens if there's x's in there. But before we get to x, let's just do a few examples with numbers still. So absolute value of 3. 3. Easy. Absolute value of negative 7. All right, so far so good. This next one here is maybe a little bit trickier. So absolute value signs are basically brackets. So you have to do brackets first. What is 2 minus 7? Okay, so you could write this like this. 3 minus 3, absolute value, negative 5. Sorry, 5 minus 3, bracket negative 5. What did I said something different. Sorry. My brain's ahead of me. This negative 5 right here is no longer negative 5. It's now positive 5. So if you wanted to write it out, you don't have to, but you could say it's 3 times just regular 5. 3 times 5 is 15. 5 minus 15 is negative 10. Common mistake. Some kids would then say, this is negative 10. I can't have an answer be negative 10. But that's not how this works. Only this little bit cannot be negative. Does that make sense? Your overall answer can still be negative. It's just the stuff inside the little signs there, that can no longer be negative. That's it.
So when you get an answer, can you just put it as an absolute value and make it positive? Like, not saying for this one, but if it was like a word problem.
Yeah, like maybe a typical example of a word problem would be, okay, I got one. You guys know how you buy like a bag of chips? And the bag of chips is supposed to weigh 50 grams. Does that make sense? But let's say that it weighs 53 grams. Well, that means you're over by 3. Does that make sense? Or let's say that it weighs 47 grams. It means you're under by 3. Does it really matter, though, whether you're over or under by 3? Either way, you're off by 3. Does that make sense? So, like, the one that becomes under by 3, you might absolute value that and just say you're off by 3. I don't care that you're negative 3 or that you're positive 3. Either way, you're off by 3. Does that make sense? That'd be a good example for absolute value where you don't care whether you're above or you're below. You want to know how much you're off by. Okay, so let's try this one here. So first start on the inside. What is 5 minus 7 going to give you? Then you have to square that negative 2. 4. Then times that 4 by the negative 2. So that's negative 8. Don't work with the absolute value signs yet. Then add 6. Okay, but now you see how the absolute value signs are like on the very outside of all that? So you got negative 2. We're going to make it just regular 2. It's not hard with numbers. It's not that useful, I guess. So like on this one here. Here you have negative 4, but you see how it's inside the little brackets, I guess, lines? So that's actually positive 4. Then you're subtracting, and then here you've got negative 3 inside those brackets, so that just becomes positive 3. But it's like still inside like a extra set of brackets there. 4 minus 3 is 1. But it's positive 1. Do I have to actually do anything to it? No, it's 1. Is that easy? Okay, here's the only part where it becomes tricky. What happens if we don't know what x is? Because x implies an unknown number. So for example, let's say x was 5. Well, then it would be 5. Does that make sense? Let's say x was 7. Then it would be 7. So there's actually 2 possibilities here. I'm just going to kind of write out possibility number 1. If x is positive, what do you do to the number? Nothing. that make sense? We don't know what x is, but let's say hypothetically x was 1. When you absolute value 1, you'd do nothing. If x was 5, you would do nothing. Does that make sense? But there's a second possibility. What happens if x is negative? Yeah, so you make it positive. But how would that look algebraically? How do you take a negative number and make it positive? What did you say? That's absolutely right. What you do is you multiply by -1 and you make it negative x. There's actually two possibilities. So I just put a negative in front of it. So let me try to walk you through this, see if this makes sense. Let's say x is positive. Let's say x is 5. Your answer would just be 5. So your answer would just be whatever x is. Make sense? However, let's say x was -5. If x was -5, if this little bit right here was -5, we don't want it to be -5. So what we do is we add an extra negative, and a double negative would then make it a positive. So you guys know how like when you have quadratics, you have more than one answer? This is kind of like quadratics. There's more than one answer. So the absolute value of x equals x, or it equals -x. Does that logic make sense? It either equals itself, because you don't have to flip the number, or you have to put a negative in front of it because you have to flip the negative to make it a positive.
So it's just x or negative.
Yeah. That's it. Whenever you see absolute values, you just do double the work. One time, you just leave it as you see it, and you do nothing different, and you solve. The other time you do it, you throw a negative in front, and you solve that. So I'll show you some examples, but let me do one more here. If I asked you for the absolute value of x plus 1, it's either equal to x plus 1, or it's equal to negative x plus 1. Good, I'm glad. That's why I leave it for last.
Why does the x plus 1 have to be in brackets?
Because whatever this whole number here is, if that whole number in brackets here was negative, then that needs to have an extra negative to make it a positive. Does that make sense? Because this whole thing was in brackets, this whole thing needs a negative. If it was like the absolute value of x plus 1, then I would make it just -x plus 1. So, let me show you how to solve some problems here then. Absolute value of x minus 3 equals 7. We're going to do this twice. First time's easy. So I like to call it case 1. Pretend it's positive. We don't know what x is, but let's say that x minus 3, let's say that that's a positive number. So maybe x is 17. 17 minus 3 would have given you a positive number, right? So just make it x minus 3 equals 7. Add 3, x would be 10. Literally just ignore the absolute value signs and just solve. Is 10 minus 3 7? Okay, that's the easy case. Then case 2. Make it bracket x minus 3, but throw a negative out front. What we're doing here is we're pretending that whatever was inside this bracket here, it must have been negative. But it's not allowed to be negative, so we throw an extra negative in front to make it positive. Okay.
I got my charger.
Oh, come on and grab it, I guess. Does that work make sense? I distributed the negative to both terms, so I made it -x and I made it positive 3. Put the 3 on the other side and then just ignored the negative and kind of flipped it around. Check your work. What is -4 subtract 3? Well, it's supposed to be -7. Does that make sense? If you put a -4 in right here, -4 minus 3 should give you -7. But then when you absolute value -7, it becomes +7. That's how you solve one of these questions. It's not harder work. It's just you got to do it twice. That's all. So let's try some more examples. The one next to it, case 1, literally just make 6 minus x equal to 2 minus 6. Ta-da. Check your work. Is 6 minus 4 equal to 2? Sure. But there's another answer. We could take 6. We could minus a number so big that this thing right here actually gives you negative 2. I can actually guess the number. It's 8. Does that make sense? Because 6 minus 8 would give you negative 2, but it would become positive 2. But let's prove why. In case 2, make it negative bracket 6 minus x equals 2. Can I show you guys a trick? You could expand the negative, and that's totally valid. Here's another little trick. Divide this side by negative 1, and divide this side by negative 1. What I'm going to do is I'm going to throw the negative on the other side. I'm going to make it 6 minus x, and I'm going to make it negative 2. See how I took the negative from this side right here? I've kind of just put the negative on the other side. Sometimes that's helpful in solving a question. I'm not saying it's always helpful, but sometimes it's helpful. So then I'll subtract 6, subtract 6. Negative x would be negative 8. So then x is positive 8. Either way, you should get 8. So my preferred method, by the way, is whenever I throw a negative in front of the absolute value, the next thing I do is I just bring the negative to the other side of the equation. I find that easier. Sound good? Okay, let's just apply this to more challenging problems then. So why don't we skip ahead to, what do I got left? I guess I only have 3 more. Let's do them all, I guess. It's not that bad. Okay, so for the first one, literally do nothing different. Just pretend those signs aren't there. X squared minus 3x equals 2. X squared minus 3x minus 2 equals 0. It's quadratic.
And then could we just leave this quadratic for you to solve it?
Well, we should be able to solve the quadratic for a couple answers, right? So unless I say solve until you get to the quadratic, you should keep going. So this guy factors, right? What does it factor to give? No, that's not going to work. X minus 3, x plus 1. That doesn't work. Because it needs to be minus 2. Does it actually work? I don't think it does it? Oh, you can't factor this, actually. Feels like you should, but I don't think you can. Oh, wait, quadratic formula. 3 plus or minus the square root of minus 3 squared minus 4, 1, negative 2, 2, 1. Just kind of breezing through that. Three plus or minus, that's 9. I got 17. Because I got 8 plus 9. 17. Did you get something different? But you have that negative 2 back here, so then a negative negative means you're adding. Did you miss that? Okay. Any questions on that one? I have 2 answers. They're quadratic formula answers. So I might say that that's case 1. Then we got to do case 2. Case 2 basically means make it negative x squared minus 3x equals 2. That works. My personal preference, though, is I prefer to make it x squared minus 3x, and then I like to make the other side negative and make that equal to negative 2. That's my personal preference, but you can solve it more than one way. So add 2 to the other side. This will be x squared minus 3x plus 2.
I got negative x squared plus 3x minus 2. Because I put the...
Okay, so you have a negative, you have a positive, and you have a negative?
Yeah.
Okay, that's the exact same thing I have. Just you have to deal with a negative sitting up front, that's all.
Okay.
My personal preference, I just prefer never to have a negative first term. That's just my personal preference. But you can still solve it based on what you have.
Yeah.
So I like this though because this one should give me this. Make sense? And then I'm done. X is 2, X is 1. Ta-da. I could even check my work if I really wanted to. These guys are ugly decimal numbers, so I might use a calculator for that, but I can do these ones in my head, I'm sure. 2 squared would be 4. 3 times 2 would give you 6, but 4 minus 6 would give you negative 2. But you would ignore the negative and just make it positive 2, so that one clearly works. 1 squared is 1. You'd be minusing 3, which is negative 2, which you'd ignore the negative and make it positive 2. For these guys right here, I would just find that it's a decimal number in your calculator. Why don't I show you how, I guess, as well, just in case. So like I would type in 3 plus root 17. I would divide it by 2. And you're going to get some ugly decimal number. Some of you guys have calculators where you can like go back up and find the old value. Does anybody have a calculator like this one here, though, where you can't go up? Okay, let me show you a neat trick. Actually, it's not that one, actually. I want to show you a different trick. Go store. See how there's like the little STO right there?
Yeah.
And then go like alpha and pick a letter. I'm going to pick A. So it's store A. Okay, so you got to go alpha.
Yeah.
And then you see how like there's green letters on mine, or maybe they're green on yours? I pressed math for A. But you could pick any letter you want. I don't care what letter it is. Okay. Well, from now on, whenever you go alpha A, it will now use that number. And so here's why I think that's useful. I'm going to go A squared minus 3A. You see what I'm doing here? Like I've made my calculator say that every time I have A is actually this ugly decimal number here. So that rather than having to go back up, since my calculator can't do that, this will then give me 10.4346. Hope I did that right. Let's try that one more time. 3 plus root 17 divided by 2. I think I didn't store A correctly. Because it should have been 3.56. Did you guys get something different when you did 3 plus root 17 over 2?
I got 5.06.
Okay, let me try one more time. 3 plus root 17, press enter, divide by 2. I think I screwed it up. I think it should be 3.56.
Yeah, I got 3.5.
Okay, let me try that again then. So I'm going to press store. I'm going to store this as, I don't know, F. Then when I use F squared minus 3F, it gave me 2. That makes sense? If you're a person who has a calculator where you can literally just go up and find the old number, I would just do that. But if you have a calculator like mine, like store it as any letter you want. And then that way you can do exactly this. So then I can try like 3 minus root 17 divided by 2. This is the ugly dumb decimal number. I'll then store it as B, I guess. And then make it go B squared minus 3B. And if I did this correctly, this should equal 2, right? And hopefully it'll give me 2. You guys ever see that before? Is that helpful? Wait, why don't we skip ahead to the last one? We'll just go to this last guy here then. So I think you guys get the idea. Okay, so for this guy here, we need to treat it once as though nothing ever happened. So pretend that sign's not there and just make it x squared plus 4x equals x squared minus 6x minus 3. Pretend there's no symbol there. How do I solve this then? We have x squareds on both sides. Perfect. Add 6x to both sides. 10x equals negative 3. Divide by 10, divide by 10. X is negative 3 over 10.
Wow.
You're able to follow that one? Okay, the other one's a little less fun. So then for the other one, I make it x squared plus 4x. But now I have to throw a negative in front of all this stuff. Could I save a step though and just flip all the signs? Would that make sense if I made it a negative x squared, a positive 6x, and a positive 3? Yeah, see how I put the negative in front and I just made everything flip its sign? Will the x squareds cancel this time? Unfortunately not. So we actually have to make it 2x squared minus 2x minus 3. Quadratic formula or factor? Well, you can do both, I guess. We'd need numbers that add to give negative 2 and multiply to give negative 6. Actually, I'm not sure that those numbers exist. Let's just go to the quadratic formula. You'd have positive 2, because the double negative would become positive. You'd have negative 2 squared minus 4, 2 minus 3, 2 times 2. There's 2's everywhere there. Stop me if I'm going too fast. You'd have a 2 here. You'd have a 4 on the bottom. That's 4. 8 times 3 is 24. You're actually adding. I have 28 under the square root sign. Can I do anything with that? Did everybody else get 28 under the square root sign? Okay, 28 doesn't actually square root, but we can reduce it. What multiplies to give 28 that's helpful? Why 4? So would it make sense if I went to 2 root 7? Because 28 is 4 and 7. 4 square roots to give 2. I'm just throwing that 2 up front. There's one more thing you can do then. See how all of these guys here are divisible by 2? So you could make this a 1. You could also make this guy here a 1. I won't even write the 1 though. And then the 4 would just be a 2. If you want the reason why that's valid, I'll just put it over here. What you're actually doing is you're factoring out a 2, which leaves you with 1 plus or minus root 7 over 4. And then this 2 and this 4 are canceling. So how many answers do we have then? One answer here. And technically this is 2 other answers. I'm going to save time here. I'm just going to call it a day. I think you guys have the hang of it. I hope you do. Check your work. Well, I mean, we just spent 5 minutes checking your work, but if you're doing the work, I'm sure you guys can check it though. Does that make sense? Okay. I say this a lot with absolute values. I always leave it for last for this reason. It's not harder work. It's just more. You have to do it twice. So do it once as though you don't even see those absolute value signs there. Just ignore they exist. Do it a second time, and you have 2 options. Either put a negative into that side of the equation, or if it's helpful to you, take the negative to the other side of the equation. That's it. and just solve it twice. What happens now though is rather than having no answers or one answer or two answers, now you might get 3 answers, you might even get 4 answers. So you might get lots of answers now rather than just getting like 1 or 2 of them. Okay, so that's it. So like I said to start class, make sure you know how to factor and expand. Make sure you know how to work with quadratics. But to be honest, we work with quadratics with all of these questions anyways. So make sure you're comfortable using square roots, fractions, and now add absolute value to the list. So tomorrow I'll show you guys what your test on Thursday looks like. And then on Tuesday I'll show you what your unit test looks like. So you guys have an idea of what to be ready for. I would say the biggest issue is just execution. Stop making mistakes. And you guys are going to do great. Okay, go take a break if you need to, or whatever.
Do you have an assignment for us?
Yes, did I give you one?
No.
Okay, let's see if I have one nearby. Actually, no, I do have one right here.